Okay, let's look at 23 through 25. This is condensing. When you're condensing, the first step is to make your exponents reappear. So I see I've got a big 3 right here. Let's go ahead and bring it up as an exponent of 3. So now I'll have log of 2 to the third power, which is 8, plus log of x minus 4. Since I've gotten my exponent back up to the top and I simplified it, now I'm going to take my addition and change it to multiplication. So take this log right here and pull it to the front and multiply 8 times x minus 4. That's going to give me the log of 8x minus 32 as my final answer. On number 24, once again, this big 1/2 has to go, so we're going to change it to an exponent. Remember, when you have a fraction exponent, that's actually a radical. So if you have 324 to the 1/2, what you have is the square root of 324. If you can't remember what that is, you can do second x squared to calculate your square root. So we have log base 5 of 324 to the 1/2, which is 18, minus log base 5 of 2. To condense this, pull the log base 5 to the front. 18, which is in front of the subtraction problem, is your numerator, and 2, which is behind your subtraction, is your denominator. So you end up with log base 5 of 9 as your final answer. On number 25, let's bring 3 up as an exponent. And so we'll have the natural log of 6 to the third power minus, bring your 3/2 up as an exponent, and you'll have the natural log of 4 to the 3/2. So let's deal with both of these. 6 to the third power is 6 times 6, which is 36, and 36 times 6 is 216. Okay, now we've dealt with 1/2, but what do you do with 3/2? So we know that because it has the half down here, you're going to be taking the square root of 4. The square root of 4 is equal to 2. Now this top number, which is normally a 1, we don't ever bother with. But now that it's a 3, that 3 is actually going to be the exponent for our number. So we'll have 2 to the third power, which is 8. So again, if you have a fraction exponent, you know the denominator is the root of your radical. So if you have the natural log of 1/2, you're taking the square root of that number. And so the square root of 4 here is 2, and then whatever the numerator is, that's your power. So 2 to the third power is 8. Now pull the natural log to the front. 216 is the numerator, 8 is the denominator. So we get the natural log of 216 divided by 8. Let's see, 27. Let me double check myself. Yes. All right, now on the next one, we're expanding. When you're expanding, you're going to have a log for every part of your multiplication or division problem. And you're going to get rid of all your exponents. Now, I have an exponent on the outside of this parenthesis, so the first thing I'm going to do is power to a power. You have a power of 2 raised to a power of 3, so multiply those two together. Then with the y, you've got a power of 5 raised to a power of 3, so multiply 5 times 3 to get 15. Now that you've done that, notice that you've got multiplication. We're going to expand it by putting a log base 3 with each part of this multiplication problem. And when you get to the multiplication part, put a plus sign. Okay, so since we've expanded, now take your exponent of 6 and put it in the front as a big number. And bring your 15 to the front as a big number. And this is your completely expanded form. On number 27, let's deal with this exponent of 4. So we'll have the natural log of 2 to the 4th power. And then the denominator, it has an exponent, so you have the exponent of 3 to the exponent of 4. So multiply 3 times 4 to get 12. I notice that I have 2 to the 4th power, so that's something that I can simplify. 2 times 2 is 4, and 4 times 4 is 16. Now to expand, you'll do the natural log of your numerator minus the natural log of your denominator. The natural log of 16 is as good as it gets, but this 12, we need to bring it to the front of the natural log. And I have the natural log of 16 minus 12 times the natural log of a. Now before you can do number 28, you have to get rid of the radical. So you'll have log base 4 of p to the third q to the 10. Since it's a square root, its fractional exponent will be 1/2. And then just like you did on 26 and 27, do power to a power. So you're going to multiply 3 times 1/2 first. And that will give me 3 times 1, which is 3/2. Then you're going to have 10 times 1/2, which is 5. Since this is multiplication, let's separate it into addition. And now bring your fractional exponents to the front. You'll have 3/2 times log base 4 of p plus, bring the 5 to the front, 5 times log base 4 of q. And that's your simplified expression.